China's ambitious plan to build a space power station capable of providing electricity for 100,000 years. The genesis of an ambition. The concept of harvesting solar energy from space is not new. Scientists and visionaries have long dreamed of capturing the sun's energy in space, where it is unobstructed by atmospheric and weather conditions, and transmitting it back to Earth. However, it is China that has taken concrete steps to transform this dream into a potentially world-altering reality. China's space agency, in collaboration with leading research institutions and tech corporations, has initiated a multi-phase plan to construct a space-based solar power station. The project's ultimate goal is to establish a power station in geostationary orbit, approximately 36,000 kilometers above Earth, capable of beaming solar energy back to the planet. Technological foundations and innovations. Building a space power station requires overcoming numerous technological and engineering challenges. The project involves several groundbreaking innovations. Solar array deployment and maintenance. The solar arrays, which will be deployed in space, need to be enormous to capture sufficient energy. These arrays are designed to be lightweight yet highly durable, capable of withstanding the harsh conditions of space. Advanced robotics and autonomous maintenance systems are integral to ensuring the longevity and efficiency of these arrays. Wireless power transmission. One of the most critical aspects of the space power station is the ability to transmit the harvested energy back to Earth. This is achieved through microwave or laser transmission technology. The energy is converted into microwaves or laser beams, which are then directed at receiving stations on Earth. These stations convert the beams back into electrical power for distribution. Energy storage and distribution. To ensure a constant and reliable energy supply, even during periods when direct transmission is not possible, the system includes advanced energy storage solutions. These storage systems can hold vast amounts of energy and distribute it as needed, ensuring a steady supply to meet fluctuating demands. Space assembly and construction. Assembling and constructing a power station in space necessitates precision engineering and advanced space robotics. Modular construction techniques allow for the gradual assembly of the station, with components launched into orbit and assembled by autonomous robots. Phased implementation. China's approach to this monumental project is methodical and phased, ensuring that each stage builds upon the success of the previous one. Research and development, 2020-2030. The initial phase focuses on extensive research and development, including small-scale experiments in orbit. This phase aims to perfect the technologies required for solar energy collection, wireless power transmission, and robotic assembly. Pilot projects, 2030-2040. During this phase, China plans to launch and test pilot solar power stations in low Earth orbit. These smaller-scale stations will validate the technologies and provide valuable data to refine the system. Initial deployment, 2040-2050. The first full-scale space power station will be deployed in geostationary orbit. This station will serve as a proof of concept, demonstrating the feasibility of large-scale space-based solar power generation and transmission. Expansion and optimization, 2050-2100. Following the success of the initial deployment, China will expand the capacity of the space power station network. This phase will focus on optimizing the efficiency of energy collection, transmission, and storage systems, ensuring the scalability of the technology. Environmental and economic impacts. The potential environmental and economic impacts of a space-based solar power station are profound. Environmental benefits. By harnessing solar energy in space, China aims to significantly reduce reliance on fossil fuels, thereby cutting greenhouse gas emissions and mitigating climate change. The consistent and abundant energy supply from space could also reduce the need for land-based solar farms and wind turbines, preserving natural habitats and reducing land use conflicts. Economic advantages. The Space Power Station project represents a significant investment in technology and infrastructure, creating new industries and job opportunities. The reliable and virtually limitless energy supply could drive economic growth, reduce energy costs, and enhance energy security for China and potentially the world. Challenges and considerations. While the prospects are promising, the project is not without its challenges. Technical and engineering hurdles. The sheer scale and complexity of building and maintaining a space power station present formidable technical challenges. Ensuring the reliability and efficiency of energy transmission over such vast distances is a critical hurdle that must be overcome. International collaboration and regulation. The deployment of space-based power stations requires careful coordination and regulation to avoid conflicts over orbital space and ensure the safe operation of the system. International collaboration and agreements will be essential to address these concerns. Economic viability. The high initial costs of developing and deploying space power stations must be balanced against the long-term benefits. Ensuring the economic viability of the project will require careful planning, investment, and potentially new economic models. The vision of a sustainable future. China's ambitious plan to build a space power station capable of providing electricity for 100,000 years represents a bold step towards a sustainable and prosperous future. By pushing the boundaries of technology and engineering, China is not only addressing its own energy needs but also contributing to global efforts to combat climate change and ensure a sustainable energy future. As we look to the stars, the prospect of harnessing the sun's energy in space offers a glimpse of a future where humanity's energy needs are met without compromising the health of our planet. This visionary project underscores the potential for innovation and international collaboration in addressing the most pressing challenges of our time.